All right, welcome back everyone. Let's go ahead and look over the solution to the Now You Try problem on solving an application to a rational equation. So here we have pretty much the same scenarios we had in the previous problem. We're just going to kind of be going through the same motions. We wanted to keep this problem pretty much exactly the same as the last one so that there wasn't a whole lot of having to sleuth and think through where this function comes from or understanding the units or anything like that. So same kind of scenario. We have a boat trip. We're going 16 miles downriver and back this time. The river is now going at 3 miles per hour instead of 2 miles per hour. And we're now driving the boat instead of rowing. The same idea. If we drive the boat at a constant rate, we've got the motor set at a constant speed of v miles per hour for the entire trip. We can model the total time it takes for the trip with the function t of v equals 16 over v plus 3 plus 16 over v minus 3, where t is the time in hours. So in the previous video, went ahead and described where this function comes from, how we come up with this function so that it makes sense. And I'm not going to go back through all of that now. If you want all of that understanding, please watch the previous video. Here we're just going to dive right in where we want to graph the function and use it to determine the rate we should row if we want to complete the trip in 10 hours now. And then we'll determine the same value symbolically. So let's go ahead and pull up GeoGebra. I still have the stuff from the last one on here. Let's get rid of that. We want to enter the function t of v equals 16 over v plus 3 plus 16 over v minus 3 to get a graph of the function where the outputs, the vertical values, are times, and the horizontal values are the speeds that we are rowing. Now we want to find out how long or how fast we should go if we want to complete the trip in 10 hours. So we want to put a y equals 10 in here and look for that intersection. And it looks like it's occurring right here. But let's just confirm exactly by typing intersect of t and f. And then again, it's giving us the first one off to the left here, and we want this one. So we'll just say between 0 and 10. And sure enough, it gives us this point at 5, 10. And that 5, that's our input. That's our speed that we want to row to complete the trip in 10 hours, the output of that function. Let's go ahead and copy this and get it in our worksheet over here. Take this and drop it in, shrink it back down since this software makes it way too big. There we go. And so we can see that the answer should be that we should row 5 miles per hour. We'll just write a single conclusion after also doing this symbolically, but that is the answer right there. Okay, so let's do this symbolically now. So to do this, we want to set the output. T is the time, so that's what we're given is the time, and we want to find the v value. So I said t to 10, and then I don't know v. We just bring the rest of this down from our function, and we want to solve for v. So I'm going to multiply both sides by the common denominator, which is v plus 3 times v minus 3. And we need to do that on both sides to keep everything even here. And so we'll start working through this. On the left side, I will FOIL these out. The middle terms will drop out. We'll get a v squared minus 9 after foiling there. Keep that 10 outside of the parentheses because we still need to multiply that by the whole thing. And then on the right, the v plus 3 times v minus 3, both of these are going to distribute to both of these terms. So I'm going to draw this all out, make sure we're not misunderstanding what I mean by that. both the v plus 3 and v minus 3 are being multiplied by the first one, and then they distribute over the addition to the second fraction. 16 over v minus 3 is also being multiplied by v plus 3, v minus 3. And so on the right side, we can cancel the it's not letting me switch colors. The v plus 3's can cancel, and then the v minus 3's can cancel in the second term over there after the plus sign. And so on the left side, we'll have 10v squared minus 90 equals, on the right side, the 16 will come down. The v plus 3's canceled, but we're left with the v minus 3 times that 16 there. And then plus the 16 again comes down, and this time is multiplied by v plus 3, which is what is left in that term. I'll bring the 10v squared minus 90 down, and then distribute the 16 across the v plus 3 to get 16v minus, oh goodness, 16 times 3. 16 plus 16 is 32. And then I'll add another 16 to make that a 48. And then we'll distribute the 16 across this v plus 3 to get 16v again, and then a plus 48. Now the 48s are going to cancel. So we'll have 10v squared minus 90 equals the 16v's add to 32v. And then again, we want to set this to 0, subtract everything to one side because we have a quadratic. We've got a squared and a first term here. So we want to move everything to one side. 10v squared minus 32v minus 90 equals 0. Then we'll see if we can factor anything out here. I can factor a 2 out for sure. All of these numbers are even. So we'll have 2 times 5v squared minus 16v minus 45 all equals 0. And then we need to be able to factor 5v squared minus 16v minus 45. This looks like it's going to be enough that I want to use the AC method on this. I'm going to do 5 times negative 45. It's going to be a bit of a long one, but bear with us here. We've got 5 times 40 is 200. This is 200. And then 5 times 5 is 25. And this is all going to be a minus. So this is going to be negative 225. 5 times 45 is minus 225. And we want to find factor pairs of this that add to negative 16. 1 and 225 would be our first option. 2 doesn't go in. 3 does go in here. I can tell that because 2 plus 5 is 9, and 3 goes into 9. That's a nice little technique for telling if 3 goes into a number. It works for 3s and 9s only. But telling how much goes in is going to be harder. 75 is my first guess. 75 plus 75 is 150, plus another 75 is 225. And that comes from familiarity and just doing way too much arithmetic than I like to admit sometimes. 4 doesn't go in because it's not even. 5 definitely goes in, and we just saw that it's 5 times 45. And then 6 doesn't go in because 6 is 2 times 3, and 2 doesn't go in. 7's a question mark. And so the way I'm going to think about 7 is 7 goes into 210, and then we have 210 to 225 is 15 more. So 7 doesn't go into 15. So 7's not going to work. 8's not going to work. 9 will work. And if I multiply 3 by 3, I get 9. So if I divide 75 by 3, I'll get 25. And I can stop right here because 25 minus 9 is 16. Or I'll say negative, or plus 9 and minus 25 is negative 16. So if we take 5v squared minus 25v plus 9v minus 45, then we can group the first two and group the second two. We'll get 5v out of the first two. It leaves us with v minus 5. And then plus 9 can come out of the second 2 and be left with v minus 5. And we can pull out a v minus 5 here, and we'll be left with 5v plus 9. Keep in mind, if you want to review the AC method and see more of that, if that's not something that you're feeling super confident on, please go back and look at that factoring section where we're solving quadratic equations, and look for the where the leading coefficient is not 1, where we have to use that AC method potentially. So, all right, now that we've got that, we can just switch the 5v squared minus 16v minus 45 into v minus 5 times 5v plus 9 equals 0. And so we have 3 things being multiplied, a 2, a v minus 5, and a 5v plus 9 being multiplied to equal 0. So one of them has to be 0. It's not the 2. The v minus 5 could be 0, or the 5v plus 9 could be 0. Solving these, we get v equals 5, or v equals negative 9/5 after subtracting 9 and dividing by 5. And so from this, we have to use the positive answer because we're not going to be rowing backwards. And that agrees with what we came up with on the graph. And symbolically, we'll now go ahead and write out our conclusion that if we row, or if we drive, this boat has a motor, if we drive the boat at 5 miles per hour, the total trip will take 10 hours. All right, that's it. That's what we wanted to do with this problem. Again, go back to the previous video if you want more in-depth explanation of how that function works. Otherwise, great job, and we will see you in an upcoming video very soon.